Hey guys, I'm Yuki Watanabe. I'm an engineer from Databricks data company, and one of the full-time co-maintainer of MLflow, which is a MLOps tool. So today I'm gonna introduce evaluation-driven development as a technique to how to build your agent with confidence and deliver it confidently into production. And as a tool, I want to introduce MLflow 3.0. So starting from the one question, so what is the number one problem in the agents? We're handling a lot of problems in this domain. We're still dealing with a lot of challenges, but what is the number one thing? The short answer is quality. So we did a big survey last year, and to all the ML practitioners, data scientists, and also like agent builders, the number one blocker for organization to launch agent in production was actually quality. And it's quite challenging to make sure your LLM or agent actually behaves properly because LLM is like not deterministic. It's very unpredictable. Also, they accept like free-form user input for most of the application. This has so much freedom compared to the like, numeric tensors we were dealing before with deep learning or traditional machine learning. Also, quality has many aspects. It's not only single metric like accuracy, but there are many different aspects you need to assess before launching your agents for production. Also, there are a lot of moving pieces in a single agent application, such as LLM, like the search tools. So whenever you want to update something, it can break your agent. But one great solution is kind of emerging in the industry, which is called evaluation-driven development. So conceptually, it's very similar to test-driven development, which is a software-driven technology to control your development with tests as an anchors. So similarly, evaluation-driven development uses evaluation as a cornerstone of your agent building. And there are roughly 5 pillars in this process, starting from data collection. So good evaluation always requires good data, and building. So you need to write some code or maybe like local tools to develop a new agent and apply some new method. And it often requires like trial and error a lot of times. And then once you have some working agent, you get to evaluate it manually. So having human check is still very important step to ensure the quality bar, and it's time consuming. So the next step is automatic evaluation. So you want to automate it so that you can scale it to many versions or many agents. And finally, once you get confident, you deploy it to the production and the monitoring will start. So machine learning projects should never end at first launch. So we need to continuously monitor the application performance and detect any regression or any concept drift or improve the system. And with that like paradigm in mind, we just released MLflow 3 is a kind of redesigned version of the entire MLOps platform so that it can work with both classical ML and agent LLM or Gen AI system. And the foundation of the fundamental tool we use for this evaluation-driven development paradigm is a tracing. I think today's session, like a lot of today's session actually talks about tracing. So I think it's kind of obvious that it's important, but let me just briefly introduce that again. Hopefully it's not too duplicate. But so tracing is a kind of observability solution for your LLMs, models, RAGs, and agents. So fundamentally, it captures various information about your agent execution, so including intermediate steps. So you can think of this as a type of structured log. But when we talk about traces in this ML literature, it's mostly tailored for general debugging, evaluation, and monitoring. And for instance, this picture is a trace. It's a trace generated for a single lang graph agent execution. So you can see the trace visualize the execution as a tree in the left side view, and the view include like many steps such as LLM calls or tool calls or other like long chain tunnel processes. So and on the right panel, you can see input and output captured for the selected step. In this case, it's a LLM call. So you can see metadata like model name or available tools. So by looking at those intermediate steps, you can easily understand and debug your agent execution, as well as using those data for evaluation and monitoring. And since tracing is such a foundation of the evaluation-driven development, we try to make it very easy to adding tracing into your agent or stack. So we provide one-line automatic tracing integration for overtraining different LLM providers and frameworks such as OpenAI, LangChain, DSPy, Panatic AI, or Bedlog. There's so many good, great libraries over there. So for those libraries, you just need to add MLflow something outlog. For example, if it's a lang graph, it is MLflow LangChain outlog. The MLflow automatically inspect your code execution and generate traces like a previous example. And the generated traces are conform to the standard called OpenTelemetry. I think the previous talk also talked a lot about OpenTelemetry, but OpenTelemetry is #1 industry standard specification for observability. And since we conform to this standard, you can use MLflow traces not only with MLflow backend, but also another observability platform like Datadog, Grafana, or New Relic, or even LangFuse or more. So this significantly de-risks the vendor locking, and it's very, very open. Yeah. All right, so this is the intro for tracing. Let's get into how we use it for evaluation-driven development. I started with building step for the sake of easy slide like organization, but the actual order is not super important because it's cycle. So during building phase, the primary work is to write code to define your agent and kind of casually iterate on it until you kind of get some working result. And while there are many great frameworks to define your agent in a very simple and easy syntax, doing something more than tutorial always requires trial and error. So tracing really helps debugging errors or issues during this process. When you enable auto tracing in a notebook or manually instrument your code, MLflow will display the trace within the notebook right on the cell output. So you can see what happens inside a framework call in the cell and debug and what data is passed between steps. And you can easily see debug any exceptions from the agent or encode the issue in the answer and quickly iterate on it. And after you build a kind of good agent, the next step is evaluating it. It can be manual evaluation by yourself or maybe asking feedback from others. However, managing those feedbacks is tricky. So you might need to manage a bunch of spreadsheets with feedbacks from like different people you ask feedbacks, or maybe different criteria or different versions. So, and you need to have it for different version of agents. So to make this simple, MLflow support annotating feedbacks on traces directory. So on the right part of the trace UI, you can see assessment section. So here we can put various feedbacks about the agent. For example, if the output is correct, if it matches with the expected like context, if it calls correct tools, or some things like that. And this feedback are then persisted on traces with metadata such as who added the feedback, or what is the rationale of the feedback, or what's the history of that feedback. Like we can also like override feedbacks to kind of correct like improper feedbacks. So since feedbacks is often come from like multiple people, or also like even if you're a single person, like you have different sense of feedback in like over time. So this metadata helps a lot to keep track of how and why they were generated. And also, sometimes you're not like expert on the domain, so you need to engage people who are familiar enough with the domain to getting feedbacks. But the thing is, those people are not necessarily MLflow fan. Like they don't have business with MLflow, like MLOps tool. They just know domain, and they might not be like technical person. So many times you don't want to share the MLflow UI directly to them, and also like, you need to access control all the other like artifacts like models or runs metrics. So to resolve this problem, and also introduce the feature called labeling session. So labeling section is a shareable UI-based annotation workflow that is designed easy to use by non-technical users. So just like in this video, you can create a session and add traces to there. Then you can share the session URL directly to stakeholders or like those domain experts. And then they can open the link and see this labeling session UI and start inputting their feedbacks. And those feedbacks will be then synced back to the traces so that you can use it for evaluation later. So by using this labeling session, you can effectively collaborate with those non-technical folks to correct feedback without basically without asking them to understand MLflow. Okay, so now we have human feedback. So next step is automation. And one common technique for automating the feedback process is using LLM or agents. This is so-called like LLM as a judge. And since LLMs are very intelligent and capable, they can give somewhat trustable feedbacks about your agent if given the proper instructions and examples. And this is pretty kind of useful technique, but however, we found people have two problems roughly in evaluation. So one is the writing this judge, LM judge itself is tricky. This is the another agent development. So it's just non-trivial effort to write a good instruction to let those judges output consistent and accurate feedbacks. Another problem is tracking the result evaluation is kind of tedious. So running a single eval is fine, but when you start to have multiple versions of agent, it quickly becomes challenging to keep the evaluation result linked with each version, each parameters or environment settings or those important informations. So it's easy to lose track and this is good result, but what prompt I use or what kind of parameters we use. So to tackle this problem, MLflow offers an evaluation suite that natively integrates with tracing and feedback tracking. So with the new API, MLflow.GenAI Evaluate, you can directly evaluate the traces or dataset with various built-in LLM judge metrics. So this allows you to take advantage of automated judges built by our research team without spending a lot of time-consuming tuning processes. Also, you can create your custom judge as well with natural language, which is pretty easy to onboard. And the evaluation result will log to MLflow tracking server with a comprehensive lineage between prompts, parameters, models, or runs. So you can easily keep track of agent versions and evaluation linked together. And moreover, while those judges are kind of great and convenient, we also see a lot of limitation in the real-world scenario. In many projects, those general judges are not great. You also need to define your custom metrics or judges in them when you get deeper. So MLflow allows you to define such custom evaluation criteria as well. Basically, you just need to define a function and decorate it with a scorer decorator. So inside this function, you have access to model inputs, outputs, or trace, and also grant truths or labels annotated on it, which gives you pretty much almost flexibility to define evaluation criteria. For example, you can extract the document retrieved in the agent from the trace and pass it to the precision recall metrics. And also this gives you an ability to plug in other evaluation libraries such as RAGAS deep checks in just a few lines, like this example below. And the evaluation result will be like this. So it shows metrics and aggregated metrics and also individual scoring scores on the traces. So to dig deeper into particular response, you can click on each row and open up the corresponding trace to find the root cause, if it is hallucination, you can just take the context return from the retriever, if it's sufficient or not, or you can do that kind of root cause analysis. And you can also open another tab in this view to see the input model, input agent version, or all the parameters, or not linked to the notebook, or those important lineage information. And so far we talk about manual and automatic evaluation, but full evaluation is typically limited. So especially for LM or agentic system, user input is very dynamic. So it is challenging to create a static data set that represents like all the real traffic. So production monitoring is must-have to make sure your application works as expected in the real environment. So in MLflow 3 and with Databricks platform, you can set up production monitoring system with tracing in just a few clicks. The only thing you need to do is enable the MLflow tracing, configure the storage to Databricks, and set up monitoring configs such as what metrics you want to compute. And you can even use a custom scorers you define locally, a defined offline version, so that because MLflow supports saving and loading in the scorers. So this is pretty powerful because you can use unified way between offline and production monitoring. And once the monitor is set up and the production trace comes in, you can see the chart on various metrics like this, including operational ones like latency, errors, because counts, and also quality metrics you define. The computation is totally doing backlog jobs. You don't need to worry about that. And if you spot any errors or issues on the dashboard, you can click on each bar to see the list of traces in the bar. So you can easily do root cause analysis and reproduce the problem as well, because trace captures inputs and outputs. And the last piece is dataset collection. So data is a fuel of evaluation-driven development. It's crucial. However, we hear a lot of organizations actually have challenges in building a good data set to drive this process. So you often start with a small manual data set or public available one, but as your project grows, you will start to also grow the data set. For example, when a user complains about like, hey, this answer is wrong, you want to add it to your evaluation data set, so you can validate the fix is actually works, and also make sure we don't do regression. So to track this dataset, MLflow natively support dataset management. So that we can create a dataset from the directory by writing input or output things, but also you can create dataset from traces by picking the actual traces from a list. And yeah, for example, you can create a dataset from the production logs from the traces those are given the bad user feedback. And you can just integrate with your deployment pipeline with automation, like automatic iteration. So whenever you update a model, you can ensure like it won't cause the same mistake again. So in summary, we covered this. So far, we covered these 5 pillars. And summary, MLflow tracing helps you to, in each step of evaluation-driven development, and allows you to iterate your agent fast and confidence. And MLflow 3 makes it like streamlined by the features like feedback tracking, evaluations, and monitoring. And we support entire like end-to-end lineage in this process. So you won't be like lose track of your like very important like deliverables. Okay, so then how we can get started with MLflow 3? So MLflow 3 is released last month, and it's already available in the PyPy. So you can just install it from pip using pip or UV or whatever package manager your favorite. And also visit the new website to see new features I introduced, like tracing or feedback tracking. And then we created a documentation with a full of tutorials for the new features, so you can just easily get onboarded with those every features. And the features I covered in this talk is just a small subset of MLflow 3 release. We have way more updates we cannot cover here, like full text search for traces, end-to-end lineage, prompt optimization, or TypeScript SDK. So a lot of things are coming or released. So please check it out. And we are also waiting for the feedbacks on all the new features we launched. Okay, so this is my closing slide, but last but not least, we have a kind of free managed service in the Databricks. So MLflow, open source MLflow requires like setting up some environment and also spin up the like server, so which is sometimes a bit tedious. So we are trying to make it simple. So you have a managed version in Databricks that you can just sign up with your email, and you will get the MLflow tracking server by free. So yeah, you can just find the link from this QR code, but yeah, it's we highly recommend checking out this as well. All right, so I think that is all for my session, and I think I'm doing good for the time. So I think we can uh, go to the Q&A session.
You're doing great on time. You're making my life easy, which I enjoy. Actually, keep the QR code up while we chat. There's a few questions that have already come through the Q&A, but I want to make sure that we give people time to type in their questions. Sometimes there's a flood and a flurry of questions. Are monitoring capabilities only available on Databricks content?
Yes, currently monitoring is only available in the Databricks, but we are currently making so we are currently trying to open source things from Databricks to there. So we are in the huge effort of like putting all the release we did for ML3 to open source, and monitoring is one of them. So please stay tuned. It will be available in I think there's a few months.
Man, I have to say, I loved that you incorporated in the idea of like experiment tracking into the agents and how you can now have this experiment tracking with agentic runs, which is so good because how much of our agent building is just exploration.
Hmm. Yeah, exactly. I think experiment tracking was like has been there for classical deep learning, but the framing was very like fixed, right? We have a like training, we have evaluation, validation, and then we deploy. But we realized that in the agent specifically, the path is very like random. We
Yeah.
do a lot of random search. So we're just we want to make sure the people have some anchors on the trajectory, and which is evaluation. So evaluation is a tool we found to make it tractable. So
But you aren't helping with the agent memory, are you? So if it is able to complete tasks, it has like MLflow is not helping the agent remember these task completions or paths that it took.
yeah, MLflow is not trying not to be opinionated on any like agent architecture or
Mm.
frameworks. So currently it's not in the scope of us, but yeah, more like we're trying to track the version of agent, or if you build a good agent with good like memory mechanism with some framework, we are making sure you track that, you don't lose that. But
Yeah.
we are not trying to like build a basically reinvent the wheel that is done by a lot of great frameworks.
Excellent. There's another question coming through from Manish. Do we have custom LLM operations in MLflow coming up as well, or is it already there? I mean, like good features around pre-training, SFT, and RLHF.
Yeah, absolutely. We are so that is an interesting area that the fine tuning is a kind of bridge between traditional machine learning, deep learning, and this agentic era. So definitely want to cover it. And one of the good thing is, yeah, we're doing that for I think 5 years to make deep learning traditional ML like great experience. So MLflow is a great intersection between those two areas, and especially for like if you're in the transformers, you can track the transformer model in MLflow with like hyperparameters and metrics. And interesting area is like also something some people use like DSPy is
Yep.
as a tool of like tool of intersection. So you're like doing kind of tuning of your prompt just like you did for PyTorch, but you're building agent. And we are also like doubling down in that direction. So that is also kind of interesting thing I want to share here.
Yeah, that's awesome. Uh, so I think that is it. I'm looking for more questions, but I don't think we have any at the moment. Now, the MLflow team, you work with Ben Wilson quite a bit, I think, right? And he's come on here and given plenty of talks. I absolutely enjoy it 100% when he does. I now are putting you into the category of folks that I enjoy listening to talk about MLflow. I mean, MLflow is like something that I think every data scientist is familiar with, and the ML engineers, we like came into our own with MLflow, and so it's nice to see that it's extending into the agentic era.
Yeah, absolutely. We are doubling down there, and also, yeah, I'm very looking forward to whenever like events from your agent community. And yeah,
All right, last one from my side for you is, what was one of the biggest surprises or gotchas as you were building out these new capabilities?
yeah, the big surprise is not a surprise, but it's like how dynamic or how sometimes people are like intelligent in building those agents. So that makes us sometimes cause us headache of, for example, we want to save the land graph agent, but sometimes people do a lot of complex agent building them and asking about like, can you serialize that? And we are like, oh, but and also it same happens with evaluation as well. Like people sometimes build a very complex evaluation process and can MLflow do that? And yeah, we are trying to catch up with those new techniques or any demands. But
Mhm.
sometimes it kind of surprised me like how intelligent people are and how smart people actually like build things in a way.
Yeah, one thing that became very clear to me after all of the incredible talks today was how research is being done by everyone out in the wild with this agent building. It is
Mm.
literally like Devin from Dosu said, yeah, we're doing research in this area. And so it's not just research that's happening in the labs or at the universities and academia, it is companies that have specific use cases and problems that they're encountering as they're building their agents who are doing the research.
Yeah, absolutely. I think also like boundary of research and engineering are becoming like big and big. So
Mm,
we are kind of we need to have some sort of research in mind always. Also like have sort of some engineering. So it's very exciting era, but it's also like challenging sometimes.
yeah. Yuki, this has been awesome, man. I really appreciate you coming on here. We've got some closing notes, and you're going to start your day. I'm going to end mine. I'll
Yeah.
see you tomorrow, maybe. Otherwise, thank you so much for coming on here.
Yeah. Thank you so much for organization. Thank you.
Cheers.